Hello everyone, thank you for joining us today. My name is Christopher Marion and I am a CAM specialist for SolidCAD here in Canada. I'm here today with my colleague Robert Pitchnich from SolidCAD, as well as Christopher Crane from Autodesk. I'm going to handle the technical presentation here, but Rob, Chris, and I will be here to answer any questions that might arise during this session. Today I thought I would do a presentation on what FeatureCAM users have access to with their Fusion 360 entitlement from their software subscription. We know that FeatureCAM is a very strong standalone CAM system that can drive most any piece of equipment in your shop, ranging from your 3 and 5 axis mill over to your multitasking turn mill center. Since FeatureCAM is a feature-based CAM system, it automatically applies operations to the defined features on my part. For example, if there was a hole feature, FeatureCAM would detect that hole and apply a center drill operation, a drilling operation, a chamfer operation, and maybe a ream or a tapping cycle. This makes for very fast programming and generation of NC code. So I'm sure you've heard of Fusion 360 by now, but what is it for? Fusion 360 is a cloud-based integrated CAD/CAM simulation tool that gives its users very powerful design and making tools. First, if you can think of a part you want to bring to life, you can use the different types of design tools like sketching, sculpting, and modeling. Fusion works with surfaces, solids, and meshes, and you can take advantage of the cloud computing with generative design. On the manufacturing side, you can go ahead and create toolpaths for mills, lathes, your 3D printer, and much more. Lastly, the simulation tools allow you to analyze your part for any structural defects before sending it to the manufacturing stages. So in today's webinar, I'm going to go through a possible solution you have access to, being FeatureCAM users. We will focus on creating a basic holding fixture for this difficult to hold part for a second operation. We'll look at importing a part file into Fusion, creating a project, creating the fixture, and then re-exporting it back into FeatureCAM for CAM programming. So with that, let's go ahead and take a look. Okay, for time constraints today, I've already gone ahead and imported my file and placed it into my vise, as well as place it onto my Haas via FOR table. So let's go ahead and program this part for its first setup. So for this, I'm going to use automatic feature recognition. For those of you who might not be familiar with FeatureCAM, this is just some technology that we can extract all of the features, whether it be a pocket, a hole, a slot, from the model and automatically apply all the operations to it. So you can see on the operation list on the right-hand side, we've got all of our operations and all of our features on the left-hand side. So I'm going to quickly modify some of these features. So for side 1, since we're going to incorporate a second setup, I'm just going to minimize the depth of this operation to 1/4 of an inch. And let's go ahead and add the chamfer. Let's go back to side 2. And let's go ahead and add the chamfer there as well. And for side 3, or the pocket, I'm going to machine this right through the part. And we'll add the chamfer there as well. For the hole patterns on the outside, I'm just going to drill this right through the material as well. And for these holes in the second pattern, I'm going to change the classification from a plain hole over to a threaded hole or a tapped hole. And these are 1/2 inch 13. Okay, so in order to generate some NC code for FeatureCAM, we're going to go ahead and run a simulation. Running a 3D sim will also show me if there are any gouges or collisions, which everything looks to be okay from this vantage point. And most importantly, we've got our NC code on the right-hand side, which we can now send over to the machine. So first setup was pretty easy to program. Now, when it comes to the second setup, we're going to have a little bit of a difficult time holding this in a standard vise just because of the profile of the part. So we might have to create some soft jaws for maybe another vise, or in this case, what we're going to do is create a holding fixture on the right-hand side of my VF4. Now within FeatureCAM, I could go into the Construct tab and I could construct a fixture using some of the solid modeling tools. The problem with that is just the associativity factor doesn't exist. So doing this in something like Fusion 360, that is an actual CAD tool, might give me some more control when it comes to those parameters. So let's go ahead and take a look. Okay, so looking at Fusion 360 perhaps for the first time, we can see the file that we're looking at in FeatureCAM also resides over here. That's because I used Fusion 360 to construct this file for FeatureCAM. And we're going to continue on with that today by building this fixture over on the right-hand side of my file. So just a quick overview of what Fusion 360 has. It has different workspaces. So right now we're working in the design workspace in the CAD environment. But if I wanted to venture into, say, maybe the CAM environment, I can go into the manufacturing workspace. And I could program this for my mill by using some of the toolpaths that are present here. For the remainder of this webinar, we're going to strictly stay in the design workspace. You also see the application bar at the very top. This will hide or expand my data panel on the left. We also have our file options for saving and exporting files. One thing you're also going to notice is the timeline on the bottom. This allows me to go back to any point in time in my design. And if I wanted to insert a function here, I could. And I can also go back into the highest point of my history. Okay, so strictly talking about the data panel here, we can see the files here that we're working with. Here's my file for FeatureCAM, my original bracket, and then I also have a drawing. And this drawing, if I double click on it, will open in the canvas. The part drawing can show me critical dimensions and give me important information on tolerances and callouts from the designer. So let's go ahead and close that. Go back to our original file. So let's go back into the data panel and we'll go to the home screen of the data panel. And you can see I've got a bunch of different projects here. This one project, my master files, if I double click it, you can see that I have some folders structures in here based off different components I might use for machining setups. So let's go ahead and go into this FCS component library. And right now I've got just this 80 mil stud. So we're going to go ahead and upload a new file. So we'll click on the upload button. We're going to browse to the file. And we're going to hit open. I could also drag and drop it. And as this is uploading, I'll just kind of talk about different ways of manipulating the file. So one is the view cube. It's the same view cube that resides over in FeatureCAM. We can also use the mouse for orbiting, control for shift, and then we have shift for zooming in and out. Now I have these controls set up because if I go into my preferences, I've got my orbiting controls to mimic SolidWorks. So this is about as close as I could find that kind of behaves the same manner as what FeatureCAM can do. And for those that use the right mouse menu in FeatureCAM, if you right click out in the graphic space, we also have the panning, zooming, and the constrained orbits here. Okay, so that file is completely uploaded. Just going to double click it to open it. And we can see it contains no history or no timeline at this point. But if we did add something to this file, we would see that timeline appear. So we're not going to be working with this file today. I'm just going to go ahead and close it. We'll jump back into our original file here. So let's go back to the master files, and underneath fixtures, we're going to create this fixture in this folder. And we're going to create a new project or a new design. And I'm going to save this new design as fixture plate job 001. Now, the very first thing we're going to do is we're going to bring in our bracket into this file. So we're going to right click on this file and we're going to insert it into the current design. And one thing you're going to notice is that next to the file, the component that we brought in, there's this link. That's because if I were to change something on the original file, it would track it forward into our new design here. So this is where the associativity properties come into play in Fusion 360. There are ways of breaking this link. So if I didn't want any associativity to it, I could break the link. But for this example, we're going to leave that link intact. So the very first thing we're going to do is I'm going to take this file and I'm going to rotate it. Let's cancel that. Let's do that one more time. And we're going to rotate it 180 degrees around the y-axis. This will mimic our second setup. And I'm going to go ahead and hide this stock for now. And we're going to go ahead and create a sketch. So we're going to create a sketch on our XY plane. And the very first thing I'm going to do is just draw a simple rectangle. And I'm going to dimension that rectangle to 12 inches. You'll see the rectangle expands. And let's go 8 inches. And we're going to finish the sketch. Okay, so I'm going to select the inside of the sketch and I'm going to extrude it down. Let's go 1 inch. Okay, let's go ahead and create another sketch. And we're going to go ahead and sketch the slots for our T-slots on our table. Okay, so let's go ahead and create a sketch on this top portion of our plate. And we're going to go ahead and create a slot. And I'm just going to sketch it out in space. And we'll dimension it. And the distance on my slots on my table are 3.15. Like so. And then we're going to use some constraints here so that the slot center always stays on this edge of the outside of the plate. So the same thing before, we're going to use this sketch to extrude through the plate. Right click, extrude. You can also find the extrude function up top. So as I extrude up, it always wants to join. If I extrude down, Fusion automatically thinks that we want to cut through our original object, which in this case we will use. Okay, so there's our one slot. Let's go ahead and create that same slot over on the right hand side as well as in the upper half of the plate. So let's do a mirror function. I'm actually going to select the extrude from my history timeline. So you can see how it's highlighted. And then we're going to rotate or mirror off of the YZ plane. And I'm going to do that again. And I'm going to grab the mirror and the original extrude. And there we go. Okay, so let's go ahead and hide this bracket. And I'm going to add some chamfers. I'm going to select the entire plate, and we're going to add a 60 thou chamfer. Now, one thing I noticed is that I just don't have a lot of meat on the outside of my bracket wall, or the slot wall. So what we'll do is go up into my original sketch, which is sketch number 1, and I'm going to edit that sketch, and I'm just going to change this dimension to say 10 inches. And we're going to finish the sketch, and you notice that the entire drawing just updates. So that's where the strength of Fusion comes into play here. Okay, so let's go ahead and add some screw locations for these 1/2-inch screws. So again, let's create another sketch. This time I want to sketch on the top of my plate. And I'm going to project some geometry down to the top of the plate. So I'm going to hit P on my keyboard. And I'm going to select this edge. Like so. And I'm also going to select the edge of this inside of this pocket. And we'll talk about why we're doing this in a second. And OK. And we're going to finish the sketch. Okay, so I brought more geometry than I needed, but that's okay. So let's go ahead and create a hole. And we're going to create a tapped hole at these locations. And it's basically going to cut a 1/2-inch threaded hole through my plate. Now it's just going to be the tapped hole size, but it's going to show that it is a threaded hole. Like so. Let's turn our bracket back on. And let's go ahead and add some screw locations. Now before I do that, we can see our bracket is kind of floating up in space. Okay, so let's go ahead and bring this bracket down, or bring the plate up to the bracket. So we're going to measure from the bottom to the top of the plate, which is 0.36. I'm actually just going to click on this value here to copy it to my clipboard. And let's move this bracket down, or in this case up, because the original UCS of this part, we flipped it 180 degrees. And that should be right on top of the plate now. Okay, so let's go ahead and add some screws. Now I could save these screws off in, say, my master files, or I can go up into the insert function here, and we're going to insert some components from the master car library. So let's look for that 1/2-inch 13. And it's basically looking in the website for the screw itself. Let's look for 1.5 inches. And now at the very bottom, we're going to insert a 3D step file. Okay, so I'm going to use the first move function here to move it out of the way. Let's rotate this 180 degrees. And let's move it point to point from the bottom of the screw head to this first location. And just to speed things up a bit, I'm going to copy that screw and Control V as paste. And I'm actually going to do that 2 more times. And we'll move these individually. So we'll go point to point. The first location will be there. And the last screw. Okay, so there's the 4 screws. Now, one last thing we might want to do is put some kind of mechanism in here so that the part can't move on itself. Because right now we're just holding it down with these 4 cap screws. For repeatability, I mean, we want this thing to be in the same location every time. So we could maybe put some dowels in. But in this case, I copied that geometry from the inside of that pocket. And we're going to use that as more or less like a locking mechanism. So let's go ahead and create a new component. And I'm going to call this one locking insert. And I'm going to call this style A, because we could create multiple different inserts. We can reuse this plate for similar part families. Okay, so the very first thing I'm going to do is create a sketch from the top of my plate. And I'm going to create a rectangle. Let's do that one more time from the center. And let's dimension that rectangle to 2.5 inches to, let's go 3.5. And before we get out of the sketch, I'm going to add some fillets, 1/2-inch fillets, that's fine. Like so. And we'll finish the sketch. And we're going to select the inside of that new sketch. And we're going to extrude it down. Let's go 5/8. And this is going to be a new body. And we're going to extrude the top portion of the sketch up 3/8. And we're going to join it to the original component. So we can see we've got this component here. Before we get out of it, I'm just going to go ahead and add some chamfers. And I'm going to add one more chamfer at the bottom. Like so. Okay. And before we move any further, I'm just going to go ahead and undraw the sketches. Collapse that down. Let's do a subtraction from our original plate to this new body. And we're going to make sure we keep the body. Okay, let's go ahead and add our plate back in. And I'm pretty happy with what we have here so far. So let's go ahead and save this. And we're going to jump back into our original file for FeatureCAM. And we're going to add this fixture back in. Right click, insert to the current design. Okay, I'm just going to drag this out. Let's bring this over 12 inches. And again, I'm going to move this down to the top of my plate. So let's do a measure from the bottom to the top. Copy that to the clipboard. And let's move this down, whatever that value was. I can't remember, so I'll just do a paste. And we want to move it negative. Like so. Okay, so let's go ahead and save this file. And let's export this for FeatureCAM. So we'll call this version 7. Actually, let's close that. I didn't select the file type. So let's export this once again. And we're going to export this as a step file. Okay, so it's ready to bring over into FeatureCAM. The very first thing we're going to do is just select all of these bodies from our original setup. And I'm just going to go ahead and delete them. And we will get a little bit of a warning, that's okay. Let's go ahead and import our new setup. And when the import results wizard pops up here, I'm just going to close the dialog. And I'm going to expand the solids here. And the first thing I'm going to do is take the two solid entities, which is body 123 and body 1-9. I'm going to go ahead and delete these since I don't need them. And I'll explain why in a second. Then I'm going to take this body. I'm just going to rename it to part 2 for setup 2. And I'm also going to rename this one as part 1, just so I know exactly what these files are. Okay, and then I'm going to take the remaining bodies and I'm just going to reconvert these to clamps because I might have lost the designation. Okay, so use solids as clamps. Then what I'm going to do is I'm going to import this STL into FeatureCAM. And what this STL is a mesh representation of our stock, the stock in setup 1 and the stock from setup 1 to represent what we're starting with on setup number 2. So if I zoom in real quick, you might see this mesh file. How I did that is when I ran the 3D sim in the setup number 1, I saved the simulation results as an STL, and I just spent some time translating it into location and re-exporting it. Okay, so after I export that or import that STL file into FeatureCAM, I'm just going to go into the stock properties, and underneath solid stock, I'm going to swap it to this STL. And let's go ahead and run AFR for the remaining setup here. So that would be part number 2. So this time though, I'm not going to select all the features since I don't require a face operation since the part thickness is already the size. I'm going to keep hole 1 through 4 but remove 5 through 8. These ones are the 1/2 inch tapped hole we got from the first setup. And I'm going to remove setup 3, or sorry, side 3. This would be the pocket we roughed in from the opposing side. I'm going to go into this whole feature and I'm going to change the depth to 0.615. Let's go into side 6. I'm going to add the chamfer, and I'm also going to change the depth since we already went 1/4 inch from the other side. And for side 7, I'm also going to add the chamfer operation. Okay, so I'm just going to zoom out here real quick. Let's go ahead and run a 3D sim. So one thing you're going to notice that there's a gouge, which is why we run a 3D sim. And it's most likely because setup 2, or side from setup 2, I haven't contained the toolpath within this region. So I'm going to go up to construct, and I'm going to construct a rectangular pattern from this point to this point. Okay, so we're going to take that curve now, and I'm going to go into side 6. And now let's run that 3D sim once again. So you can see we've got setup 1, setup 2, no gouges.
Chris?
Hi, Rob.
Hey, I do have a question, a nice technical question. Someone's asking if we can use the FeatureCAM post that they have on Fusion 360.
And yeah, unfortunately, no, it doesn't. They don't cross-pollinate that easily. But the good answer to that is you can go up to. There's a site that we have that has, I think, over 100 different free post processors for Fusion. So if you have something like a Haas VF, like was kind of shown in this demonstration, most likely you will be able to find a post processor for that machine on that site. So let me just go ahead and I'll share my screen. I'll just go ahead and show you where that is. Okay. Let me just open up Google here real quick. And if you go to, it's a HSM post site, so it's cam.autodesk.com/HSM posts. So if you just kind of look through this site, you most likely are going to find a post processor for
Chris,
your
we don't
yep.
see your screen. We still see the main screen.
Oh, okay. Sorry about that.
Yeah, that other screen there. Thank you. In the
Can you see
meantime,
it? Okay, there we go.
Yet. It should be coming up soon.
Let me see. You still can't see it, Rob?
Oh, I cannot see it now.
Okay, well, I'll put the link to the site when I share the video out, so that way people know where it is. Any other questions?
Yeah, a couple more. One of the first questions I answered, but I just figured I'd ask it is, they're off of subscription or they're off of maintenance on their FeatureCAM. Do they still have access to Fusion 360? And the simple answer is no. That your entitlement to Fusion 360 with FeatureCAM is only when you're on a current subscription or current subscription. So, but can you get Fusion separate? Yes, you can, at a very reasonable price. And we got one more question here. Where was the project function in Fusion 360? Not very clear on that question.
The project function?
Is it the project? I read it as
the project.
Project. Sorry. Yeah,
that's
project.
okay. Yeah, so the project function in the demonstration that I showed was located by just pressing the P on the keyboard, which is a hotkey for that function. But the actual function, I believe, is underneath the create drop down.
It is.
Yeah.
Yep.
It's pretty easy to find. It's in the drop down menu there.
Once you're in the sketching environment, you can just hit P as you said, or you drop down under the create function.
Yep.
Which is a great point. Those hot key shortcuts inside of Fusion are well worth experimenting with and picking up on. They're very helpful.
Yeah, and they're quite similar to very much the AutoCAD environment, where it makes it simple for people to transition from AutoCAD to something like a 3D system like Fusion 360, L for line, C for circle, that kind of stuff.
Yeah, that's why this webinar didn't go too in depth into the design world or the CAD world. Try to keep it pretty basic for the people that are just creating these type of fixtures for machining. But there's a wide breadth of assembly functions and design functions in here.
I don't see any new questions. So.
No new questions. Okay, well, again, we'd just like to thank everybody for showing up again today. We'll go ahead and we'll exit out of this meeting, but look forward to doing more of these. Just so you're aware, we'll be doing a 2-part series webinar on PowerMill next week, just intro to automation. So look out for that if you're interested. You can always go to the SolidCAD website. Underneath the events, there's the manufacturing events page. You're going to see a bunch of different webinars we have set up in the future, some for HSM, some for FeatureCAM, and some for PowerMill. So look forward to those if you're interested. Just pop by our website and check them out.
Yep, and just one more thing to add. If you guys do have questions after the fact, our email information is there on this last screen. Chris will be sending out the video to all the attendees. You can always respond with your questions there as well, and we'll be glad to help you out.
Thanks a lot, everyone.
Bye-bye.